Now we come to the 5G architecture, and first of all we are going to discuss the functionalities of the gNB or the next generation node B. The first and the most important functionality of the gNB is the radio transmission reception with the user equipment on the air interface or the wireless channel. And because gNB is responsible for communicating with the user equipment on the wireless channel. Then the second functionality is the digital signal processing. For example, the voice and the signaling that is going from gNB to the user equipment that needs to be encrypted. The data and the signaling that is going to the user equipment needs to be encrypted on the air interface. Similarly, the data and signaling that is coming from the user equipment to the gNB needs to de-encrypted, so or decrypted. So this functionality is performed by the gNB. Similarly, the data that is going from gNB to the user equipment, it needs to be compressed so that on the air interface it occupies less bandwidth. So this data compression is done by the gNB. Similarly, the data that is in compressed form and is received from the user equipment, it is decompressed by the gNB. After that, it is important to understand the difference between the two types of signaling from the aspect of the access network. One is called as the access stratum signaling. Access stratum signaling is that signaling which is going on between the user equipment and the gNB. It may be during the call, or it may also be when user equipment is not in a call. So as this signaling is only between the user equipment and the gNB, so this access stratum signaling is processed by the gNB. The other type of signaling is non-access stratum signaling. Non-access stratum signaling is that signaling that is going on between the user equipment and the core network. So gNB does not process this non-access stratum signaling. Rather, it relays this non-access stratum signaling from that it is receiving from the user equipment to the core network. Now we come to another very important function of gNB, which is known as the radio resource management. In a cell which is controlled by one gNB, you can have many mobiles. So in order to provide service to all these mobiles, gNB needs to manage its radio resources. What does it mean? Like gNB has to decide that what resource blocks are being allocated to these user equipment in order to satisfy their demand in terms of data and the quality of service. Similarly, gNB also needs to decide that at what power it is going to transmit towards the mobile and at what power the mobile is going to transmit towards the gNB. This is called as the power control, and the purpose of power control is that there is not too much interference for the other user equipments that are nearby and which are using the same wireless channel. Similarly, gNB is responsible for the communication with the core network, and similarly it communicates with the nearby gNBs. And why it is important? There is a link between two gNBs which is known as XN interface. So when a mobile is moving from the coverage area of this gNB to the coverage area of this gNB, then in that case, when this mobile enters the coverage area of the other gNB, it attaches to that gNB. So in order to, and this is called as the handover. So in order to do this handover, there needs to be a signaling between the two gNBs over the XN interface. So gNB is responsible for handling that signaling.